Hi, welcome to the StrataCode web demo preview. I'll show you StrataCode in action, but first a few slides to set some context. When I run StrataCode with two layers, in this case the program editor and the unit converter, those layers bring their dependent layers in and sort them. And then StrataCode organizes these layers, in this case, into two runtimes, one that's converted to JavaScript to run in the browser and the other that runs on the server. And StrataCode lets you synchronize overlapping layers automatically. And when you do need to use remote method calls, if they're in data binding expressions, StrataCode can implement them automatically as well. And in general with StrataCode, we organize the code according to dependency. So this lets us reuse more code. So the program editor, most of the code is reused between the desktop and the client server versions. And when I run StrataCode with the -dyn option, it makes that layer and its dependent layers dynamic on the server. So on the server we can update the code and update the instances and detect when we've changed a compiled class and need to just restart. It'll just take a little longer. And in the client we don't really need the dynamic mode because we can just patch the JavaScript code because it's already a dynamic language. So that's enough of an introduction. So let me run StrataCode with the program editor and the unit converter in dynamic mode. And then we'll go to the unit converter, which is a simple little application. It can be updated in both directions. So, then I'll open up the program editor and we can look at the code for the unit converter. So on the top here I have the types organized by their Java type name, and then on the bottom the files are organized like they are in the file system, broken out by layer. So we see that unit converter is organized into 3 layers, which are also shown up top here. So if I start with the model layer, the base layer, we'll look at the code view, and it looks a lot like Java, only there are objects and bidirectional data binding expressions here. And then in the core UI, this is sort of the shared user interface between all the versions. We add essentially the view model properties, the number converter and current converters. And then this is the HTML specific UI, and it looks like an HTML template, but there are some special attributes, and you can put data binding expressions inside of HTML attributes just by prefixing the expression with the operator, a little bit like an Excel formula. So this is a fully declarative template, and so there's not a lot of code, but let's take a look at the generated code. So this is template gets converted to StrataCode first in the process of converting it to Java. So here we're doing the modify again to modify these previous 2 layers, but this time it's extending a new class, this HTML page class. The head and body objects are defined in HTML page, so we modify those as well. And then if we look to the converter choice that implements the selection here, we see those data binding expressions just get copied in, and the template is reactive using data binding. So when this select tag changes, it updates this value, and this value changes, it invokes this method that then will at some time later cause this method to be called to re-render that attribute. Let's look at the generated Java code. So now we're merging all 3 layers together. And since unit converter is a dynamic class, there might not be a class here at all, except it extends this HTML page, which is a compiled class. So since we need this dynamic stub to represent the boundary between the compiled world and the dynamic world, but it doesn't have any logic in it. We'll look at the client Java, which is more typical of the compiled StrataCode. So it's just a bunch of patterns used over and over again. We convert fields into getSet methods and send binding events. We inject code to do synchronization. We convert objects into classes with getX methods. And then some objects have component conversion done to it, so they can do arbitrary graph-based object initialization. So now let's look at how that gets converted to JavaScript. So essentially this is the JavaScript that looks the most like Java that we could make it. So it's the exact same method names, and it's relatively easy to go back and forth when you do have to debug the generated code. So let's look at how synchronization is done in StrataCode. So I'm going to turn on the trace sync option, and I'm just going to put the number 100 here. So now we see the traffic that the client is sending to the server, and you see that it just updates this one value. But that allows the client to keep the server in sync with everything that's going on, with everything that's been synchronized. So when I hit refresh, you'll see that all the synchronized state is restored. The only thing that wasn't synchronized was the source menu item here, and that the server is actually returning the HTML that has all that dynamic data in it. So that value 100 that we typed in comes back in the static HTML. So the browser is going to display that as quickly as possible and then start loading the JavaScript afterwards. So that does actually use a session on the server, but it's really just a cache. So if I restart that server, I can still interact with the application. It just has to, now the client's going to reset the server session on the first request. So once I've connected and reset, I can hit refresh, and the server still now has holds on to that whole session. So in effect, the server's backing up the client and the client's backing up the server. You get the best of both worlds without having to write a lot of code explicitly and without having to go to the extreme to make your app totally stateless. Let's look at what it's like to modify the StrataCode application with this live programming. So here I'm going to go and update the label, and you see it updates very quickly. It actually is going to the server and patching the JavaScript to do all that. I can update the formulas as well, but let's just do something a little more extreme and go to the source code, and I don't have an editable code view yet, so I have to use Vim on the server, but I'm going to add a new converter, and now I'm just going to refresh the app. So this is going to reload all the source code, and it adds the new power converter here and updates it. As you can see, I can switch to the instance view and see that as I type, those values are all recorded. And if I go to the code view, has also been updated. So we didn't actually save that Celsius change, so it got overwritten when I did the refresh. So that's the live programming with the unit converter. So let's switch apps now, and I'm going to run an app that's in client-only mode. So this is a simple to-do sample, and it just loads an HTML file from the disk and loads the JavaScript to then run that application. But it's all very live and responsive. The only thing is that since it's only running in the browser, there's no server. When I hit refresh, it resets to the beginning state. So now let's run that app in client-server mode, and I'm going to add the program editor, but I'm going to put the program editor into dynamic mode. So now it will actually use the program editor to edit itself. But first, let's look at the to-do sample, and you'll see just quickly that now that it's got a server involved, just like the unit converter, when I hit refresh on the browser, you don't see any changes. So it's kind of fully stateful. And so now let's look at the code for the unit converter for the program editor in itself. So I'll go to tree view, and I'll look at it in the code view mode. So this is the template snippet that makes this little tree widget here, and you see that it uses data binding for things like toggling the open and close, and then the key tag is down here at the bottom where we see the repeat attribute used. So that's going to iterate this tag once for each of the children, and then it extends itself. So this is an inner class that's going to extend the outer class, and that gives us the recursive tree behavior. But otherwise it's very declarative, so it's easy to separate the behavior from the appearance and kind of tweak those independently. Okay, so let's look at the style sheet. So this is very simple template. It has some dynamic properties, and then it's just CSS that embeds those properties. But just like other StrataCode objects, it's fully live and reactive. So we'll go look at it in form view. And let's start with this rule here for 2 columns. So as I shrink the window beyond 500 pixels, we switch to 1 column mode, and then when I make it bigger, it goes back. So let's say we wanted to change that to 700. once it's gone to the server and patched the code, now we're back in one column mode. So I need to make it a little bit wider to make it 2 columns again. Or I can change this rule for the tree width to 25%. And if I switch over to code view, you'll see that it's updating just those lines of code. It preserves the comments, and it's not stomping on the developer's formatting and things. So when those rare cases maybe where you want to share a business user tool with a developer workflow, you can. But typically you would just create a new layer and give them each their own layer. Okay, one more thing I'll show here is just how StrataCode kind of scales with more rules. So there are a bunch of rules here to manage the responsive layout, because we have these heights and widths these heights are going to be a variable percentage. So let me switch on the instance mode, and you see these rules all have to get recomputed so that those percentages are all updated on the fly, and StrataCode can kind of do that just using simple data binding expressions. So it's too bad that it's so hard to do this with HTML and CSS, but StrataCode makes it as easy as possible. So one last thing I'll show is a different sample, or that same sample but including a different layer, the window scope layer. And window scope is just going to give us a slightly different feel to how the app behaves, because now instead of creating the state and keeping it per session, when I hit refresh, everything gets reset. And so let's take a look at how that's implemented. And it's just one file in that new layer that I added. So this is the HTML page class, and if you look, I'll show the template for it. This mixes in the editor into the body of the page, so that's how we merge the program editor into the to-do list sample, and it uses this order value to control whether this div tag goes after the to-do list tag. So and then in the window scope itself, all we're doing is just overriding the scope attribute of the HTML page. So that makes it use a different life cycle. So that's overriding the templates that are used to control those getX methods to just do something a little bit differently. And when you can control the life cycle of components declaratively, it lets you use this object declarative model in a lot of new ways, and also lets you reuse that code in different contexts. So that's what I have to show right now, and thanks for watching, and keep your eyes open, because I think now that this core stuff is all working, we'll see some more application level features coming out soon.